simple harmonic motion. So what is this simple harmonic motion? Simple harmonic motion is just a type of oscillatory motion in which a body moves back and forth about a fixed position. So, and that position we call it equilibrium position or equilibrium point. So when you're talking about simple harmonic motion, this is just a type of motion where an object, if it goes, it has to what? It has to come back. And the key thing to remember is this: the restoring force or acceleration is directly proportional to what? To the displacement, and always directed toward the equilibrium position. So we can represent this statement by mathematically in this way. So let's represent this by mathematically. So we are going to say acceleration. So this equation, this mathematical expression summarizes everything that I was talking about. So you are going to see that I was saying that the key thing to remember is the restoring force or acceleration is directly proportional to the displacement. So as we can see, acceleration is directly proportional to the displacement and always directed toward the equilibrium position. That's why we are seeing that negative side, because the restoring force will try to act to oppose the direction of displacement, because it wants to bring the object to equilibrium. So that's why there is a negative in that formula. So when you want to make like a mathematical expression to remove this direct proportion, we are going to say acceleration is equal to negative kx, and this formula, as you have you may see in some examples, we use this formula to find the acceleration or displacement given the values of the other things in the formula. So let's go to some examples in real life. What are the examples real life examples of simple harmonic motion? The first one is a mass attached to a spring. That's simple harmonic motion. That object will go and come back, will go. That process, we call it a simple harmonic motion. Another one is a simple pendulum for small angles, and also vibrations of a tuning fork. So those are the real life examples of simple harmonic motion. Let's go to the important terms in simple harmonic motion, even though most of them have mentioned them. The first one is mean position or equilibrium position. So this is the position where an object is not experiencing any force. It has a zero net force. So another one is displacement. Now this is distance of the object from the mean position or equilibrium position, and can be positive or negative. So that's the displacement. What about there is another one, time period. When you're talking about time period, this is just the time taken to complete one full oscillation. What do we mean one full oscillation? So the example you can get for oscillation, just imagine for the pendulum, yeah, that's the complete oscillation we are talking about. So these are the another thing is frequency. Frequency is just the number of oscillations per second. So these are the four things that the important four things you should know in simple harmonic motion. So these are the important terms in simple harmonic motion. Now let's go to another important thing we should look at, the mathematical expressions in simple harmonic motion. So in simple harmonic motion, displacement can be written as either x is equal to a cos wt plus the phase, or x is equal to a sin wt plus the phase. So let me show it. X is equal to a cos wt plus this phase, or a sin wt plus phase. So these are the two ways we represent displacement. So how do they differ? Why is there a sign there and here there is a cos? So this cos and sign, it just shows where the object was starting from. For example, you know the graph of sine, the sine graph, it starts from what? From 0. So if the object was starting from 0, that's why we have that sign. But if it's starting from like maximum, we are going to have what? Cos. So don't be confused. Whenever you see these two, they can write either a cos or a sine. It all depends on what was the starting point. An object starts like this. So this is going to be, this is a sine graph. So we are going to use the formula which is x is equal to a sine wt. We continue. But if it starts from here, from maximum, we are going to use the formula of a cos instead of a sine. So don't be confused. Why did they start with a sine? Why cos? Yeah. Now that phase in the equation, it just tells you the starting point and the state of motion of a particle in what? In simple harmonic motion. Another thing also, what about acceleration? The formula we are going to use for acceleration is a is equal to negative w squared x. This is the formula we are going to use for acceleration. Other key points you should know in simple harmonic motion is at equilibrium x. At equilibrium, the displacement is 0. And because the displacement is 0, velocity is maximum and acceleration is what? Is 0. So when you're going to be solving exam questions, test questions, you should know that when the displacement is 0, velocity is maximum. So when x is 0, this is at equilibrium, velocity is maximum and the acceleration is what? Is also 0. So this is what happens at equilibrium. At equilibrium, x is 0 displacement, the object hasn't moved, then the velocity is maximum and the acceleration is what? Is 0. So let's take for instance, this is the spring we are having. An object has been displaced. At this one, as you can see, this object is at equilibrium. So at this point, what is our displacement? Displacement is 0. And the velocity is going to be maximum. But if you are going to have another object, it's like this. Then the object is here. Then the equilibrium is somewhere there. So what we have seen in this object is we have the displacement, which is this distance, which is x. We are going to call it x. The object has moved to the left, and this is the displacement. So when we are taking the second instance here, for example, an object is at this maximum position. Displacement is what? Is maximum. For example, the spring has been compressed to its full maximum compression. So velocity here is 0. And the acceleration is also what? Is also maximum. So it's just the opposite. At equilibrium, displacement is 0, while velocity is maximum and acceleration is 0. What about at maximum position? Acceleration and the displacement